again. I hope you are having a good day and you are ready for some chemistry. Today we are going to talk about experimental design and investigation. And this lesson is going to cover 2 periods. We're going to talk about what is science and explain a little bit what historical and observational science is and focus more on the scientific method, and we are going to go on and plan an investigation. Let's start with what is science. Science is the field of study concerned with discovering and describing the world around us by observing and experimenting. So we discover through observation and experimentation, and this has nothing to do with our opinion, preferences, or our worldview. Science is observational, applicational, and historical. And what's observational science? When the information is gathered by examining things through our senses, measurements of experiments, and when other people can check our results doing the same thing, we have observational science. And the method we use in observational science, it is the scientific method, and we're going to talk about that later. And we have applied science, that is a discipline that is used to apply existing scientific knowledge to our benefit. For instance, technology, different inventions are applied science. And we have the historical science. Historical science is a term used to describe data that is provided from past events and for which there is not usually direct experimental data in the present day, such as cosmology, astronomy, astrophysics, geology, paleontology, and archaeology. And the historical science is that part of science that gives way to different opinions and their interpretations and create these different views and opinions in the science. And I'll give you a simple example so you understand what historical science is. Let's say the building where the school is. You see this building exists there, is there. You can observe it, you can measure, you can even dig in the wall and find out what materials are used there, just testing them. But you have no idea how it was built, how it came to existence, and you cannot redo that in the same thing. It's there. But you can go in the past and you can find the blueprints. You can talk to engineers and architects and the workers, and you can get a lot of information that you can bring, a lot of testimonies that you can bring in present days. This information is historical science. We all have heard about the radiometric dating, and is used in geology. Some geologists take present-day rates of radiometric decays, rock formations, and assume the conditions were the same in the past. Assume that we had the same rates of radiometric decays, the same rock formation, the same amount of elements that are present in the past, and conclude that the Earth is too old. And we cannot zip back in time to test this with accuracy, and they cannot zip back in time to prove this with accuracy. This is historical science. Now we have two big worldviews in the world, like the creation and evolution. And you need to know that neither creation nor evolution is directly observable, testable, repeatable, and therefore neither qualifies as observational science. And we are going to be faced, when we go to college, with, maybe we are not going to go in a Christian college, we're going to be faced with evolution. And in those schools, the evolution is sold and is introduced as an exact science. And you are obligated to give back to the teachers, when you answer to the professors, the thing that they give to you. If they teach evolution, you have to answer on evolution. But please keep in mind that evolution is not an exact science. Historical science is not proven through the scientific method. What is the scientific method? The scientific method is the process used to understand phenomena through developing an hypothesis, experimentation, and learning so that we are able to predict the phenomena again. Moshe Pritzker, a former postdoctoral researcher at Harvard Medical School, told Live Science, "The reproducibility of published experiments is the foundation of science. No reproducibility, no science." The scientific method, it is the systematic way of learning about the world around us and answering questions, and goes through some steps. The first one is observation. We all have ability to observe, and we look around, we see something, and we wonder, say, why is like that? What if? And scientists are usually curious about the world, and they follow the observation with a question. And they form a question and conduct some background research. They go and look for what is known about that situation, or what is already there, what other people have discovered. And based in the research, they propose a hypothesis. Hypothesis is an educated guess about what you accept. Based in the research and based on what people did before you discovered, you form this hypothesis and you guess that something is going to come out from that. And based on the hypothesis, you design and perform an experiment. And the experiment is built in a way to test your hypothesis. And while you perform this experiment, you record data and analyze it. You look for patterns and see if the data supports your hypothesis or disapproves your hypothesis. And you draw a conclusion from there. If results do not support the hypothesis, go back and propose another hypothesis, or revise the hypothesis you have, whatever you need. And you go on with design another experiment and perform the experiment and getting data, and you continue to testing it. But if your data support your hypothesis, you do repeated testing, because you want to have these results more than once. And when you are sure that this thing happens over and over, you share the results so others can test it independently and reach those results. As Moshe said, no reproducibility, no science. So if you have reproducibility, you have science. Before we go on with plain investigation, I want to talk a little bit and refresh what theory is and law is. Theory is a well-established hypothesis with a considerable evidence and studies to support it. But it's still just an explanation. And according to this, the theory of evolution, we're used to call it theory, is not a theory because it's not a hypothesis with considerable evidence and study to support it. And the law, so theory as an explanation. Law is a statement of natural phenomena to which no exceptions are known under the given condition. It is a statement, doesn't explain anything. When Newton discovered the law of gravity, he saw this thing that was happening and was pretty clear that there was something happening. There was this force there in working, but he didn't explain what it was. He just stated this natural phenomena, and took Einstein like later to give explanation and explain why was that law in place. So law is just a statement, and there is a big misconception. The theories can become laws. This is not true. Theories cannot become laws. And the laws, we have some pretty good laws on place that we haven't seen any exceptions, like mass conservation law and others, gravity law, but laws might change also. If new things come up, the laws change. And Einstein, in fact, said, no amount of experimentation can ever prove me right. A single experiment can prove me wrong. And I wanted also to refresh a little bit understanding on variables. What are variables? Variables are any item, factor, or condition that can be controlled and changed. And when we design an experiment, variables are controlled and measured. Now we have controlled variables are the ones that are kept constant. We have to have certain variables kept the same so we can control better the one that we change. So when we measure, we have the right outcome. We write down the control variables. That this is important because that makes the experiment reproducible. And we have independent variables, are the one that we control, are the one that we change and see what the outcome is from their changing. And dependent variables are the one we measure. Independent variables are the one connected. We change one and we measure the effect on it. Now, let's work through an example. The first step, observation and research. We said that was the first step in the scientific method. Scientific investigation is a quest to find the answer to a question. So we want to find the answer to a question using the scientific method, which is a systematic process that involves using measurable observation to formulate, test, or modify our hypothesis. So the scientific method, scientific investigation, we have a question and we try to find the answer for that question, and we use measurable observations. We test in order to modify this hypothesis. The example is, during a neutralization reaction, base plus acid, we observe that the beaker gets warm. And this is our observation. The next step is we gather information, do research. We go to gather information and find out that all that is known about the exothermic reaction and the releasing of heat during the neutralization reactions. So through the research, we saw that, something that happened is something that happens with neutralization reactions. And we ask a question. We formulate a question that can be answered in a measurable way. We said it was important to answer in measurable way. Beginning with questions like what, how, or why is a good start. So, in our situation, a question that we can come up with is, does the kind of acid affect the heat released? And based on the research we had and what people before us have discovered and wrote down, we formulate a hypothesis, which is an educated guess, we said. A hypothesis is not outside of the understanding that we have now for the problem. So we ask the question, we have a hypothesis that says a strong acid would release more heat than a weak acid. We can propose this hypothesis because we read enough and researched enough about the strong and weak acids, and we found out something that brought us in this hypothesis. And after that, we design the experiment. Decide on the variables, decide on the equipments. Variables, we said three variables. Controlled ones. We are going to keep the amount of the base the same. The amount of acid the same. The molarity of acid and the base the same. Temperature of base and acid the same. And the variable that we are going to control is time. We are going to have a time that we are going to measure the variable, which is the temperature, because we're talking about the heat released. We are going to keep the time the same, and you're going to measure the dependent variable, the temperature. And something that we change also is the kind of acid. We are going to have two acids, a strong one and a weak one. And we decide on the method and procedure. So we decide to have a neutralization reaction between hydrochloric acid and the sodium hydroxide and acetic acid and sodium hydroxide. So we have one strong acid and a weak acid with sodium hydroxide. And we decide in these equipments, 3 beakers, 2 thermometers, sodium hydroxide 1 molar 100 milliliters, and hydrochloric acid 1 molar 50 milliliters, and acetic acid 1 molar 50 milliliters, and styrofoam caps, because we're going to measure the temperature and we want to contain the heat in, so we are accurate. Watch cylinders to measure volumes, etc. At this point, we have to carry out a risk assessment, way to see the safety and what the measurements we are to take to be safe. And we see in our research that the base is really corrosive, and the hydrochloric acid is the same. So we make sure that we use gloves, we use protective glasses, and not touch it, any of these chemicals. And after that, we start the experiment. And while we do experiment, we record data. Record the temperature every minute for each reaction. So we start the watch, and every minute we record the temperature and make tables. We have to keep in mind, when we make tables, the controlled variable, the one that we control and change, is registered always in the first column, and the dependent variable is registered in the second one. If you make graphs, the controlled one is always in the x-axis, and the dependable variable, the one that we measure, is in the y-axis. And after we record all the data, we analyze and draw conclusion from results. And some of the things that we answer, that we see for patterns, and we answer the questions: was the hypothesis right? And we see what can we be done differently next time. Register things that went wrong. Right? If something surprised us, write down what surprised us. And give your opinion if you need further tests to prove that. And we write the conclusion. And the conclusion now, I wrote a conclusion here because I have no knowledge of subject, but in that point, you are going to have the knowledge to be able to write a conclusion. And the conclusion I wrote was: strong acids release more energy than the weak ones because they ionize more. Strong acids need less energy to break the proton bonds, and since it's a closed system, the rest of energy is transformed in heat. So after we write the conclusion, we are done with this experiment, and the scientist goes on and repeats it, and when he's sure about it, he shares with others, and others can do it. That's why we can do today, because other people did it before. The information is there. During the experiments, be aware of error and accuracy, and that is something that you can write in the conclusions. So also, if you had a problem with that. Now, we're going to have a class work, and I wanted to work in groups of 3 or 4. And this is the problem. Making tea for your mom and dad, you noticed that sugar was not being dissolved that well in one of the mugs. Touching the mug, you observed that this mug was not as hot as the other one. Being curious as you are, scientist, you decided to investigate if the temperature of the water had anything to do with the amount of sugar dissolved in it. Now, I want you to set an investigation, follow all the steps. First, come up with a question. Come up with a question and make an hypothesis, which is an educated guess. If you don't have enough knowledge in this thing, you can go out and research, but I would guess every single one of you knows what's happening there. And after you do a hypothesis, just set an experiment. Method you will use, materials you need, variables, and decide what variable is going to be independent, controlled, or dependent. And if you want to make a skit and draw down the experiment, this is great also, and is welcomed. And I wanted to make tables to record data. Now, since you are not doing the experiment, you cannot fill the numbers there. You can just make the head, you can make a table and tell me what you are going to put in the first column, in second column, or whatever. And after that, I want to analyze and give conclusion. If you want to go ahead and put fake numbers in the data and analyze and give conclusions, that is good with me. But if you don't want to do it, you just make the table and you explain what you would derive in a conclusion if you did an experiment. This was for today. Have a good time in your this class work and blessings until the next time I see you again.